Alright guys, we are going to start by looking at a concept known as energy. Now we talk about energy a lot, you guys use the word energy a lot, but you may not be using it in the correct context, so we're going to clear that up in this unit. First of all, energy is a substance-like quantity that it produces change in the physical state of a system. Or our best definition is it's a way that we can describe the state of an object. So we use energy to describe what's going on in our system, describe the state of an object or a system. Now, last year in physical science we talked about energy through heat, or the kinetic energy of an object at specific temperatures, or through a change in temperature. You know, you guys have seen this equation before, Q equals mc delta T. You saw that in physical science when we looked at delta T being our change in temperature, and this is heat. So heating an object is a way you cause the object to gain kinetic energy through those molecules starting to move around and increasing their speed. We said that was kinetic energy of those molecules. Before we can really talk about energy and the storage systems of energy, we're going to talk about how energy is transferred. There are three ways to transfer energy. The first way, the one that we're going to look at here since it's physics, is through working or doing work on a system. The second way is heating. That's what you look at in chemistry and physical science. And the third one that we're not really going to get into is radiation, how you use microwaves to increase the kinetic energy of an object. Now, work is a transfer of energy. Think of it like you're transferring money from one bank account to another, or you're taking money out of your bank account to give to Walmart or GameStop or whatever. Now, energy is always conserved, just like mass. You can't create or destroy it. So, but it can be moved from one place to another. And so that's what we're going to look at first in dealing with work. So first of all, we need to define work. Now, work is done on a system or transferred. Work transfers energy on a system when a force causes an acceleration. Not acceleration, I'm sorry, displacement. Okay, when a force causes a displacement. Now, right now, I'm pushing down on my desk, okay? I'm putting some weight on my desk. Now I'm applying force to it, but the desk isn't moving, so I'm actually not doing any work on my desk right now. Work only happens, or a transfer of energy only happens, when a displacement occurs. Now, this equation is given as force times delta x. A key thing we're going to look at here, this is the parallel force, or the force acting in the same direction or along the same axis as your displacement. So I'm going to say along axis of displacement, and I'll show you what I mean in just a second. So first of all, let's say we have this box and we apply a force to the box. Now, we know that since this force is at an angle, it's not on my axis, we would actually say that there's a horizontal component and a vertical component. Now, if we were moving, so I'm going to say delta x is to the right, we're moving to the right, this horizontal force is along the axis of my displacement. If I was moving up or down, then the vertical force would be the force that I'm interested in, because that would be along the axis of displacement. So for this, instead of work equaling force times delta x, it would equal Fx times delta x, because this is the force acting along my displacement axis, and delta x is my displacement. So even breaking that down a little more, let's say this angle is theta. Well, if that's theta, we know that fx is adjacent to theta, and looking at this triangle here, fx would be the side adjacent, and f is my hypotenuse, so fx is f times the cosine of theta times delta x. So we will be using some trig in this unit as well to determine the work on our system. Now let's look at an example. Okay, so the example 1 is how much work is done on a vacuum cleaner pulled 3 meters by a force of 50 newtons at an angle of 30 degrees. So this is the picture that we have. This is my vacuum cleaner. Here we have the force acting on the object. Now this is an external force. When we're dealing with work, we're talking about external forces, not forces that deal with storage systems like gravity, a force that's always there, and we'll talk about that a little later. So this external force, an object coming in and pulling on your system. So it's 50 newtons, this is 30 degrees, and we move a distance of 3 meters. Now, guys, I always draw pictures. I try to encourage you to draw pictures, so please do that. Now, this force is acting at an angle. Here is my axis of displacement, and that is not in the same direction, so we know we're going to be looking at this horizontal component. So I have to figure out what that horizontal component is. I know work equals that force times our displacement. So that force is going to be 50 times the cosine of 30 degrees times my displacement, which is 3 meters. Now when I do that in my calculator, let's see, 50, nope, I've already done it. 50 times the cosine of 30 is 43, and 43 times 3 is 129. Now we got to figure out what our units are. This is a newton, and delta x is meters. So we have 129 newton meters of work. Now remember, we said work is a transfer of energy. Okay, if you moved money from your bank account to your house, you're still transferring money. And we said work is a transfer of energy, so we are transferring joules. A joule is a newton meter. 129 joules. Okay, now let's look at the sign of work. So here's a nice little picture. Negative work occurs when the force in your displacement axis is actually opposite direction of your displacement. So let's look at this example. We have a car moving to the right, but we have a force that is pulling it at some angle. So this component would almost be slowing it down, so it's doing negative work. It's not assisting in that change of motion. So our force is opposite of our displacement. Same thing here. We have a car moving to the right, however the force comes in at an angle to the left and down. So that left force is opposite of my displacement vector, meaning we have a negative work. Here for positive work, we have a car moving to the right again, and this D is our displacement. So this force is only going to cause this to accelerate even more, which means we're going to have positive work. It's doing work on our system. And in this example, we are moving to the right. We have a force coming in. The component of this force is going to be in the same direction as our displacement, so we have positive work. Well, that's all I have about work. Just remember, work is a transfer of energy. We're going to get into a lot more difficult examples, and hopefully your understanding of work will increase as we go through the unit. Go ahead and go to the next video, which is going to have 4 examples of work and how we deal with that and looking at our signs.